Hi, hello everyone. Today we are going to see about the manager of a flower shop promises delivery within 4 hours on all flower orders. The flowers are purchased on previous day and delivered to the manager by 8 a.m. Next morning. Manager's daily demand for the roses is as follows. So he has to purchase a rose and then he has to deliver the next day. So the roses in dozens are 7, 8, 9, 10. The probability are 0.1, 0.2, 0.4, 0.3. The manager he purchased the rose for rupees 10 per dozen and sells it for rupees 30. So he had a profit of 20. All the unsold roses are donated to the local hospital. So the every day is not all the roses are sold. Some days the roses are unsold, so unsold roses are donated to the local hospitals. How many dozens of roses should the manager order each evening to maximize this profit? So the question asking us to what is the maximize profit for that manager. So what is the optimum expected profit? So what is the profit for expected with this probability? So we have to solve this question. Hope you all understand. Now the solution is cost of the price of roses. So the manager purchased the rose for rupees 10, so rupees 10, and selling price of the roses is 30, so he put rupees 30. The marginal profit is the purchasing is 10 and selling is 30, so 30 minus 10 is 20, and marginal loss is he has to purchase for his capital investing for purchasing the rose is 10, so marginal loss is 10. There is no loss between this, so the loss only is he has to purchase the rose for rupees 10, so that 10 is the loss, marginal loss. Then we have to calculate the profit, means marginal price MP into demand and marginal loss into Q minus D. So MP is MP, the marginal profit into number of roses sold, and minus marginal loss into number of roses unsold. Unsold roses are calculated from the total quantity roses and total demand. So total quantity minus total demand is the left roses, so that only we have to put that Q minus D. So our marginal profit is we know that 20 into D is as it is D, and minus our marginal loss is 10, and here Q minus D. So if we multiply 10 means minus 10Q, minus into minus plus 10D, so 20D plus 10D minus 10Q. Our profit is 30D minus 10Q. So our profit can be decided as if the demand is greater than the quality, so that is a profit. Yeah, we had a quality that more than the demand means we had only a profit, that is 20D. And if we had a quantity greater than the demand, if our quantity is more, the demand is less, means we had the profit of and profit is not only the profit, there will be a loss, so that is 30D minus 10Q. So next we have to put the table. So the state of nature is what are the roses in dozens, and the probability we have to plot here. So states of natures and probability, we have to choose the course of actions. So as it is, this 7, 8, 9 are written in this side. If here is a quantity, here is a demand. So if we have 7 roses and the demand is also 7, so that is 7 into, here we have to choose because the demand and the quantity are equal, so 20 into 7 is 140. Then here as it is 8, we have a demand of 8 but we have a quantity 7, that is profit. Then we have a demand 9 but our quantity is 7, and so here also 140 and 140. Then we had a demand for 7 and we have a quantity 8, so there is a loss. So 30 into D minus 10Q. 30 into D is 30 into, here demand value is 7, into 7 minus 10 into Q is 8. So 3 7s are 21. 120 minus 80. That is 120 minus 80 is 130. So that answers. If we have 8 roses, 8 demand and 8 quantity means that is profit. So 160. The balance are terms also 160. Then we have a 7 demand but we have a 9 roses means that is a large losses. So 7 into 30 is 210 minus 9 into 9 into 10 is 220. 9 into here is 210 and 90. 210 minus 90 is 120 and here 8 roses and 8 demand, 9 quantity. So here also loss. So 30 into 8 is 3 8s are 24 minus 90 is 150. Then 9 roses, 9 demand means 20 into 9 is 180 and here also 180. Then 7 roses 10 means we have to put in this equation, that is 210 minus 10 is 110. Then here also 8 demand and 10 quantity means loss, that is 30 into 8 is 240 minus 100, that is 140 and 9 demand and 10 means that is also 30 into D is 270 minus 100 to that is 170 and here 10 roses 10 quality 10 demand means that is profit, that is 20 into 10 is 200. So this is the course of action table. Next we have to find the expected conditional payoff. So the computed below are, we have to put the states of nature and probability, and what we do in this course of action means that is expected payoff, or we have to multiply this probability with these terms. 140 into 0.1 is 14 and 130 into 0.1 is 13 and 120 into 0.1 is 12 and 0.1 into 110 is 11. So we have to multiply according to this values. So 0.2 into 140 is 0.2 into 140 is 28, 0.2 into 160 is 32, 0.2 into 150 is 50 and 0.2 into 140 is 28. Likewise also 0.4 into 140 is 56, 0.4 into 160 is 64, 0.4 into 180 is 72 and 0.4 into 170 is 68, and then 0.3 into 140 is 42 and 0.3 into 160 is 48, 0.3 into 180 is 54 and 0.3 into 200 is 60. And we have to add this column wise, and we have to add this means we get the answers of 140, 157, 168 and 167. So we have to find the highest EMV value. So here the highest value is 168. So EMV value is 168, thus correspond to the course of action. So if the manager can buy if a manager can buy 9 roses in the day before evening means if we purchase the 9 roses, the next day the 9 roses will be sold and he get the maximum profit according to this probability. The manager should purchase 9 dozen of roses every day. This is the solution for this question. Hope you all understand, and thank you.